Hey everyone, my name is Chirag. Me and Alvin both work at DoorDash. As you expect, DoorDash is heavily data-driven company, and we use a lot of cutting-edge technology, and we develop a lot of bleeding-edge technology too. And Airflow is one of them. So today we will be talking at our Airflow journey. What is the context behind it and what were the challenges we were facing and how we address it. And in this talk, we want to share our experience. At the same time, if you have gone through a similar experience of the challenges, then definitely happy to learn. And any feedback if you have for us, that's going to be very helpful. So with that, I'll start with talk. This is the agenda, pretty much challenges, our solution, and then we have our time for Q&A. So in terms of the context, right, based on Airflow Survey 2024, if Airflow instance has more than 1,000 DAG, then it falls into the biggest Airflow instance bucket. But I'll say our Airflow instance is way bigger than that. And it's not just Airflow survey. Whenever I get chance to meet with people in this summit last year, or in between, I have met with people from all the companies, including AWS, Google. I always ask them this question, that, hey, what's the size of your Airflow instance? And how many DAG it runs, how many tasks it runs every day. And based on those conversations, I very rarely found someone say the number which is higher than ours. So it's one of the biggest instance we operate on, and that comes with a lot of challenges as expected, right? In that setting, it's for now. Right now, we just have one. We had only one monolithic instance, so all of our DAG and task run only on one instance. So that was the size of it. In terms of ownership, how we operate in DoorDash is, ownerships are divided. So the DAG authors, which are primarily data engineers, machine learning engineers, and other users, they own the DAG, and we as an infra team own the Airflow infrastructure. So that is how the separation of ownership happens. So that was the context, and we knew we have to scale. We got a business need that we have to scale our Airflow instances to the multi-fold. So we were given a mandate that, hey, we have to support more and more use cases in the future, and definitely we have to watch out for the headcount cost without increasing team size. So that was a very high level, vague one-liner statement, but that comes with its own complexity. So that's the context and the problem we were facing. So to put it very simply, as expected, the challenge is how do you scale it? Now, one simple way to scale is keep adding more and more DAG to given Airflow cluster, given Airflow instance, and theoretically it should work, but that's just the theory. That's definitely not the case. The moment you start doing it and start operating at a very high scale, you definitely run into reliability issues. If reliability issues have to define, it's in the two categories. So you will see the core components such as scheduler, they start running into issue, and always the issues are not identical. Sometimes scheduler is running out of memory. Sometimes the DAG parsing is taking longer in scheduler. Similar in the web server, the responsiveness of the web server changes. So we know, by these signals that the instance is not healthy, but there is never a concrete a connection dot that why it's happening. So in short, we start getting hit on our reliability. And the same is applicable. Once you have more number of DAGs or tasks, then you will make larger number connection to MetaDB. So then you run into those issues also. So with scalability and reliability are in a way connected. So we run into those kind of issues if we simply scale without giving a thought. That is one. Given that we were in a very monolithic setting, one of the challenge we have is that whenever we make any critical upgrade, which means Airflow upgrade, Python version upgrade, Python dependency upgrade, or even we have a lot of internal operators and we upgrade them, then those changes get exposed to all of the instance in one go, and that is definitely not we want to do in a very critical production system. But I have at least spoken to other people, and I realize that is what many people do, and that is one of the reasons people are somewhat apprehensive, or they're very cautious when they do Airflow upgrades, and that totally makes sense. But these are the similar challenges we were facing. So how do we address this? So one of the approach is, we could have gone as an engineer and changed the Airflow core, right? So, but that would have impacted our business timelines because changing Airflow core is very critical. We might have to work with a lot of open source community, and there can be timeline issues and all those things. So considering that, there was another approach. Hey, you have a very big cluster. Why don't you break that big cluster into smaller clusters? Yes, and that's the approach we went with. Now, how do you break a bigger into smaller? Like, how do you do the categorization? There are multiple ways. Many people, many companies do it on the use case basis. Like, a use case is belonging to a particular use case, goes to one instance, and then they end up having 10 or 20 instances within their company. For us, we realize the right approach for us is going to be the tiering of the DAG. So we tier the DAGs with certain criticality. So just to give an example, let's say we have criticality 1, 2, 3. So DAG belonging to very low criticality will go to tier 3. Little more critical will go to tier 2, and a higher critical DAG might go to tier 1. So that is the approach we went with. So on paper, again, looks very simple. But once you have these systems, definitely you achieve scalability, reliability, and you also achieve isolation because now we have multiple clusters, so you can do a critical rollout gradually. But having this has introduced new problems. We will have a problem of fragmentation, right? So previously the owners, DAG owners, they knew where their DAG is running, which instance is running. So simply they come to UI, they search for their DAG, and their job is done. But now if you have multiple instances, then it will be a very bad user experience. They have to either remember it or they have to figure it out that where their DAG is running. So that is in terms of user experience, fragmentation. Another challenge is that a lot of our DAGs were interdependent on each other. Completion of the starting of one DAG is dependent on some previous DAG. So it was easy to manage when everything is one instance. But since we were planning to split the bigger instance into smaller one, then how do you manage the cross-instance DAG dependencies? So that is the challenge we face. Another set of challenges, like how do you migrate? Now, migration is not a one-time thing, right? There is one-time migration when you have one big instance and you split that into multiple smaller, so that is one time. But there are going to be dynamic migrations also. User will say, hey, my DAG was tier 3 yesterday, but now because of business reasons, this is tier 1 DAG. So we have to migrate that DAG. So we have to account for those future needs also. And apart from it, let's say we did tiering, we have multiple tier instances, and let's say one of the tier 3 instance or whatever, it is now getting too big for its own size. So now we have to break that into another smaller instances so that that don't run into the reliability issues. So this is also a futuristic thinking. We wanted to address this problem also when we were looking into these things. Apart from it, when you have a lot of instances, and how do you make sure that governance is right? How do you make sure that all the Airflow versions are their Python version and Airflow versions are not drifting? How do you make sure the DAG are aptly deployed to the tiering? If we go with our example, how do you make sure that no one deploy tier 3 DAG on a tier 1 cluster? So those are the challenges that comes with having multiple instances. So the second level of solution that we came up with is Orchestration Frederator. Orchestration Frederator is a layer on top of multiple Airflow instances we have that gives a quasi-unifying feeling to the users and servicing that are using Airflow. So now users and servicing, rather than directly connecting to Airflow, they connect to the Orchestration Frederator, and it internally route your request to the appropriate Airflow instances. So how does it do it? It uses DAG to instance mapping internally, where a DAG is mapped to a specific instance, and then based on it, it will be able to figure it out. And it uses the same mapping to route the UI request. Orchestration Frederator had its own UI. So what you have to do, you simply go, you search your DAG, just like previously existing Airflow instance. You go, you search your DAG, and it will automatically redirect you to the Airflow instance where your DAG is running. And this also caters to the task sensor. So now task sensor can go and ask this service that, hey, where this DAG is running, this service returns that this DAG is running on instance 1. or n, and then it will go and directly call the API server to get the status of the DAG. And that's how they're able to do the inter-instance DAG communication. So that is a very, like 10,000 feet high level view of the federator. In the next slide, in a minute, we will talk a little bit more at the detail level. But before going to that slide, right? So this is what I shared is purely the technical implementation. Now, just a technical implementation will not solve all the problem. We need to have right processes in place to make sure everything works as we expected. So in that case, we continued with our philosophy of a separation of responsibility, where the DAG, DE, MLE, and all the Airflow users have to just worry about the DAG. The infrastructure changes are still completely owned by the infra team. So what it will help us is, again, we will able to avoid the Airflow and the Python version drifts. In this case, the users of Airflow, they don't have to be Airflow infra experts. In that case, they don't have to worry about upgrading Airflow infrastructure, and all the migration related tasks will be handled by the infra team. And what does it help us? It don't overburden the users of Airflow if we have multiple instances, n instances, or if we start increasing our instances from n to n+1 or n+2. So that is a very high level view. For a little bit technical implementation, I'll let Alvin take over.
Thank you. Thank you, Chirag. Now I'm gonna use this diagram, architecture diagram, to talk about how we solve the Airflow multi-instance problem. So at high level, as Chirag also mentioned previously, we have on the upper left, it's an orchestration federator, which has a central view of all the different Airflow instance. And for each of the Airflow instance, it contains like 4 components, like the scheduler, web server, its own metadata DB. So the first question is like how we distribute the DAGs of different tiering to the different Airflow instance. So how we does that is each Airflow deployment would have the scripts that will run at runtime that will sync only the subset folders with only the subset DAGs files, and it will only parse the subset DAGs in its corresponding instance. And the second is how does the orchestration federator has a central view of which DAGs lives in which Airflow instance. How it does that is that it has a centralized DB, which hosts the mapping of which DAGs lives in which Airflow instances, and this DB syncs the most updated mapping from all of the Airflow instance metadata DB periodically, so it always has the latest mapping. And then it also has an API layer upon it to expose this mapping to either any service user or any other human users who want to access this info. And the next big part is the user experience, because now we have multiple Airflow instances, and how we make sure the user experience is still seamlessly when there are multiple Airflow instances. So the first is that the unified view. We provide a UI, which you can see on the upper left, where the user just inputs they can search the DAG. They can just input a DAG prefix and can give you the Airflow UI link of the Airflow instance where the DAX lives in, and they can get redirects to the UI seamlessly. So yeah, that's one part. And second is about monitoring. Like people used to have alerts when their DAG fails in the monolith Airflow instance, but now we have multiple. How can we make sure that their experience is unchanged? It's also down by the DB I talked about, where now the alerts would contain the links to their corresponding Airflow UI, so that's easy for them to just click on it, and the debugging experience is seamless. And third is the migration. So we want to break the monolith Airflow deployments into multiple different instances. We need to migrate from one Airflow instance to another one, and this migration should be transparent to our users. How we do that is that during the migration phase, we will host the subset DAGs in both instances, with one like enable, one another disabled, and then we utilize a open source migration utility to migrate the DAG history so that the users would see their DAG history just to keep unchanged in the new instance as well. And also migrating DAG history will make sure that there will be no duplicate DAG runs. So this all makes the user has like a seamless experience as previous monolith Airflow deployments. And the last but not least is the cross Airflow deployments DAG dependency. Like some users, they want a DAG in like deployment 1 to sense the completeness of a DAG in deployment 0. So this is done by the cross Airflow instance sensor, and it is also supported by reading the centralized the DB with the mapping of which DAG lives in which instance. Then it knows it in Airflow instance, then it would redirect to the Airflow metadata DB to get information of the completeness of the DAG. Yeah, that's everything about architecture. I'll pass back to Chirag to talk about the key results for this Airflow multi-instance.
Thank you, Alvin. So with this design and solution, we were able to address the core requirements, and definitely it has very good certain feature and the gains that we got out of it. So one is it's truly scalable now, right? So no matter like even before it, as a single instance, it has its own vertical limitation, how much it can be scaled because of the core components. But now, since you can have n number of instances and all of that are hidden behind one orchestration federator, so it's very easy for us to set up more number of instances and then scale horizontally by adding more Airflow instances. So we are able to scale. And now, since each of the instance is not operating at very close to its maximum limits, so we are now every instance and the core component of the instances are highly reliable. We also were able to achieve isolation because with this, having multiple instances, now we don't release the critical upgrades, Airflow version upgrade, Python upgrade directly on all the instances. Rather, obviously starting from lower tier and gradually going up to the upper tier, let them bake in period of time that gives us confidence. If we run into issue, that gives us time to address the issue. And along with all this, this whole initiative, if we would have proposed this initiative as a 20-team initiative within the DoorDash, that would have been a difficult buy-in for many people. So all this initiative was completely owned by the infra team, and by that it's a relatively lower investment, and we were able to achieve all of our goals. So. And we, with the UI layer and the overall orchestration federator, now there's no fragmentation because that is what the unifying part of it. It was definitely a lower effort as compared to if you would have gone into and updated the core Airflow. Apart from it, since by the process, a lot of all governance is controlled by or owned by the infra team. So that is why we have a very strong governance and consistency. So it never happened like Airflow, different instances or are drifting in their versions, Python versions or anything, because we as an infra team make sure that, any change we do is gradually, published to all the instances we have. So this overall has enhanced our operational efficiency also with the same limited number of the members in the infra team. Now we are able to support larger number of instances, larger number of tags. So that's how we were able to achieve all of our objectives. With this, while we were able to achieve everything at very high level, there were definitely some P1 tasks, I'll call them, that are still good to have. So right now, our UI is still very similar to Airflow UI, where user has to go and search the DAG. If we can give a user a personalized UI where only a given user is always interested in specific DAGs which they are interested in. So that is why, having a personalized UI and only rendering them those DAG will be a good enhancement. Currently, one of the limitations we have in our system right now is, let's say if you had a DAG on one instance and then you migrated to another instance, but the RBAC rules will not get migrated on automatically. So that's a manual step for now, but we are working on utilities as an admin team to make sure, that process is also seamless. So that is sort of work in progress. Before we go into question and answer, as I shared earlier, like DoorDash is a very heavily data-driven company. We're always looking for very smart and talented people, which I'm assuming a lot of people are here already. So if you feel any opening matches your criteria, feel free to go to the link or feel free to connect with us after this talk. And Airflow is just like one of the technology which we talked today. Apart from Airflow, a lot of bleeding edge and cutting edge technology work we are doing. For that, you can find it on our engineering blog. And feel free to connect with me or Alvin on LinkedIn. We are happy to chat about Airflow, in general data platform, or anything under the sun if you want to talk.